There are many ways of joining materials together. But take something as advanced as a modern aircraft, and you'll find it's put together with thousands of nuts and bolts and other threaded fasteners. Why? Because these types of joints are efficient, they're extremely strong, and when it comes to service or repair, they can be easily disassembled. However, whatever the product, the degree to which such fastenings are tightened is critical. Too loose, and the nut may vibrate free. Too tight, and the bolt may break. In some circumstances, this may simply be inconvenient. In others, it can be a matter of life and death.
0, all engine running. Liftoff.
Correctly tightened fasteners will, on the other hand, function perfectly for years, helping to keep products safe and in service. This is why so many leading organizations worldwide recognize the value of correct torque. Torque is a twisting force. It's measured by multiplying the force on a lever by the distance from the point of application. We all know we can tighten a nut much more easily holding a wrench near its end. If we hold the wrench at its midpoint, we need to exert twice as much force to apply the same torque. Applied torque is a measure of the tightness of a nut and bolt, but it's not actually the torque that holds the parts together. In fact, the thread of the fastener converts rotary motion into an axial load that stretches the bolt, thereby converting torque into tension. This in turn creates a clamping force between the face on the nut and the head of the bolt, and it's this force that holds the joints together. The more the nut is turned, the greater the stretching of the bolt and the greater the clamping force. The effect this has will depend on the type of joint. Broadly speaking, joints are described as being hard or soft. A hard joint is usually one where a short bolt is used to clamp metallic, non-compressible elements. A soft joint, on the other hand, may incorporate plastic or gasket elements, which will be compressed and deformed during tightening. With a hard joint, the limiting tightening factor is likely to be the bolt. As the bolt is tightened, it will start to stretch in a reasonably uniform manner. However, as more torque is applied, the bolt will reach a point when it gives and starts to deform permanently. This is known as the yield point and marks the end of the elastic limit of the bolt. Further tightening will eventually cause it to break. The objective when assembling this kind of joint is to stretch the bolt to induce the correct clamping force and to maintain a reasonable safety margin away from the critical yield point. For most applications, the aim is to achieve a tension of around 70% of the yield strength of the bolt. People need to be able to measure torque, either to specify the correct value for assembly or to check the torque of a previously tightened bolt. There are 3 generally accepted methods of measuring the torque applied to a fastener. The decision on which to use will depend on the configuration of the particular joint under consideration. In the just move test, increasing torque is applied to the fastener that has already been tightened. A measurement of the torque that needs to be applied to make the nut just start to move gives an indication of the torque that was originally used to tighten the fastener. The loosening test is very similar, only this time the torque needed to break free the fastener is measured. Comparison between the value just measured and previously established break-free values again gives an indication of the correctness of tightening. In the third method, the marking method, a nut or bolt and its adjacent surface are marked. The fastener is undone. And then retightened at the point at which the marks realign. Measuring the torque used to achieve this can give a reliable guide to the original assembly torque.